My name is Kambiz Kazemi. I am a cloud consulting engineer with Palo Alto Networks. And today we are joined by Osvaldo, who is a cloud network specialist from Google Cloud. In terms of the agenda, we are going to look at Palo Alto Networks at a glance as a company, and then we are going to switch to the partnership between Palo Alto Networks and Google Cloud and what that strategic partnership is shaping up to. Next, we are going to talk about the value proposition of the VM-Series next generation firewall on Google Cloud. Next, we are going to talk about some integration points, basically what are some of the integration points that we have from our security products to Google Cloud security products. Next, we are going to basically pass it over to Osvaldo to talk about Google Networking Fabric and its capabilities and some of its uniqueness that makes the design a lot easier for some of our customers. Next, we are going to talk about some of the architectural decision points that we have to consider before we lay out the design. And next, we are going to talk about some of the design patterns and use cases. Mainly, we are going to be focusing on things like transit VPC with shared VPCs and sometimes advanced peering. And we're going to talk about ILB as next hop, either single NIC or multi-NIC. Next, we're going to have a quick demo about one of those scenarios. And basically, then we are going to switch to what are some of the recommended instance types that you have to consume from Google Cloud for our VM-Series firewalls, and what would you get in terms of performance numbers depending on the instance type. And lastly, we're going to finish up by introducing some of the resources that basically can help you learn a little more about the solutions. So having said that, so Palo Alto Networks, we are the indisputable next generation firewall on the Magic Quadrant on the top right corner. Basically, we have 70,000 customers as of today in 150 countries, and we have 85% of the Fortune 100 companies. Next, we are going to talk about the partnership aspect. So what is the purpose of placing the VM-Series firewalls on Google Cloud? Basically, you want to protect your data and your application on Google Cloud. And we can simply do that by inserting the firewalls. If you also look at the partnership aspects, first of all, Palo Alto Networks is Google Cloud's Partner of the Year for fiscal year 2020. And we are the first cybersecurity partner to achieve the specialized security requirements that Google Cloud proposes on the Google Cloud platform. Also, if you look at the marketplace, on top of the VM-Series next generation firewall, you can see things like Cortex XDR, which is our advanced endpoint protection and EDR solution on marketplace. You can see things like Cortex XSOAR, which is our security orchestration and automation and response solution, Prisma Cloud, Prisma Access, which is rebranded to SASE, and AutoFocus. So this basically concludes summarizes some of the partnership aspects that we have with Google Cloud. Next, what is the value proposition of VM-Series on Google Cloud? We really have to look at it within the context of the shared security responsibility model. So when you move to the cloud, you might have infrastructure as a service solutions, you might have PaaS services or SaaS services. Within the shared security responsibility model, there is a boundary where the customer's responsibility and the cloud provider's responsibility are basically separated from each other. If you look at the IaaS solutions, basically VMs everywhere, the customer is responsible for everything on top of the hypervisor, basically things like operating system, access and authentication, the configuration of the application itself, access policies, and the content. When you move to the PaaS services, basically you move on top of the operating system. You're not responsible for that, but you're still responsible for things like the deployment, the access policies, and the content. And finally, when you move to a SaaS solution, basically you are mainly responsible for access policies and the content. So within that shared security responsibility model, there are different places that you can basically insert the VM-Series firewall. On top of that, the VM series firewall will give the customers consistent threat protection and prevention across cloud, on-prem, and hybrid cloud. We can design for zero trust model. And finally, a lot of times, the fact that customers need VM series is dictated by the specific compliance requirements, like PCI DSS and NIST and things like those. So these are some of the value propositions that we can see with VM series firewall on Google Cloud. One of the key questions that sometimes comes up is, well, if I have the GCP firewall rules, why do I still need a next-generation firewall? And the answer is that you really have to look at them in combination, meaning that the GCP firewall rules are basically kind of like access lists. They have visibility into IPN ports, and they can basically filter the traffic at layer 4. However, if you want to go beyond that and look at the application, basically be able to stop the exploits, malware, data exfiltration, and basically stop the threats and vulnerabilities from getting into your network, or things like anti-spyware, URL filtering, or DLP, basically you're going to be looking at a next-generation firewall solution. So this is a screenshot of what it's going to look like. Basically, when you create a security policy rule on the VM series firewall, you can select from those profiles. So you can assign a profile for vulnerability protection, for anti-spyware, URL filtering, etc., etc. Also, there is a key distinction between how you can see the logs. Basically, if you just consume the native VPC flow logs, which are very, very helpful in many cases, you can have visibility into layer 3 and layer 4, right? So basically, VPC flow logs captures the metadata of the packet from layer 3 and layer 4, and that's a really good way to have some visibility. If you want to go beyond that, you can basically take a look at the VM series firewall logs. Basically, you can get a lot more. You can actually see the application data. In this case, for example, we are seeing that a specific user from Brazil is connecting to our application. We can see the type of operating system he or she is using, the specific browser that is being used, etc., etc. So from a log perspective, you're going to get a lot more by looking at a VM series log. Next, what are some of the integration points between Palo Alto Networks and the GCP security products? First of all, and this is really the focus of today's conversation, the VM series next-generation firewall can fully integrate into the Google Cloud Fabric. Basically, we can consume the fabric. Among those things, we can consume the high availability constructs, things like load balancers and instance groups. We can leverage shared VPCs, advanced peering, ILV as next hop. Basically, that allows us to build an inline, highly scalable, and highly available security posture. So that's basically the VM series in its VM form. Also, and this is a fairly recent development, but the VM series has been ported to a containerized version, which is called CN series. So basically, if you have Kubernetes deployments inside GKE, you can basically deploy the CN series firewalls as containers, and these are going to be deployed as daemon sets on every single node that you have within a GKE cluster, and thus provide protection not only for north-south traffic, but also for east-west traffic. Basically, traffic between different pods can also be secured through the CN series solution. And lastly, when it comes to the VM series, we now do have a solution for IDS. Basically, there are cases that customers are looking not for an IPS solution, but an IDS solution. They just want to have visibility into the attacks that are coming into the network. And that solution is available now, and we basically rely on GCP packet mirroring solution. Beyond the VM series firewalls, there are also other integration points. Basically, if you go to Cloud Security Center from Google Cloud, you can see that you can add Palo Alto Networks Autofocus and Prisma Cloud as a source. So basically, you can bring the threat data from Prisma Cloud and Autofocus and basically combine that into your security command center and basically have a single pane of glass for all the threat data and the information that you're looking for. At this point, we're going to pass it to Osvaldo to talk about Google Cloud's Fabric networking capabilities and some of its uniqueness that will help the customers design a highly scalable, highly available security posture in the cloud.
All right. Thank you, Canvas. Hi everyone. We're going to cover a little bit about the Google Cloud networking. So as Canvas mentioned, my name is Osvaldo Costa. I'm part of the Google Cloud networking specialist team. So can you go to the next one, please, Canvas? So starting with our network that you guys can see that everyone can see on the map. We can see here the regions which are highlighted here as the larger blue dots, and also the zones. Typically, those regions, they'll have 3 zones, with the exception of a US Central that has 4 zones, and also the new regions which are highlighted in white here, the roadmap regions. And this information is also available on our public website. Besides that, you can also see our edge points of presence, which are the smaller blue dots that most of the times they will overlap with the CDN edge points of presence. So those, they are very important because when exposing your application publicly, for example, with the Google Cloud Load Balancer, then when combined with our premium tier, then the traffic will enter our network via those edge points. And the edge points and also the regions and the zones, they are connected together by using our physical network that is highlighted here with not only the terrestrial links, but also the submarine cables that we have. So the combination of the physical network and the logical network that we have, that our software-defined networking allows us to deliver the concept of a global VPC. So effectively speaking, what's possible, the benefit that the customers can have is having a single VPC that can span across those 24 regions or more when they become available. So within that VPC, the global VPC, which is global, inherently global, you can have multiple subnets which are regional and not zonal. So you can have multiple subnets in those regions, as I mentioned, and those subnets, they are configurable, but they are also expandable. So you can expand them at any time without any downtime. Those subnets, they support both RFC 1918 and non-RFC 1918 that was recently released. And on top of the concept of the standalone VPC, then we also have available the concept of shared VPC that allows sharing the networking resources with what we call service projects. So that makes your administration much easier from a configuration perspective, from monitoring and operations. And we're going to cover that a little bit more in detail. On top of that, also our global network offers another benefit, which is our Anycast-based cloud load balancing that provides a single IP, being v4 and or v6, that's globally available and leverages our infrastructure. And as I mentioned in the previous slide, traffic will enter via our edge POPs. And also something that was recently announced is our global bring your own IP. So for those customers that own their own blocks, they can bring those blocks to GCP and have us advertising on behalf of the customers and assign those public IPs to the resources, for example, to the load balancers. That said, I mean, what are the benefits that having a global network, a global VPC, right? So the first one is makes your life easier from a management perspective. So instead of having to define multiple VPCs and then explicitly connect them together, you can have a single VPC to manage all the resources. And that will also help in terms of, from a network security perspective, since all the firewall rules, for example, they can be defined in a centralized manner, since they are configured at the VPC level but enforced at the instance level. So you will have a single point of view where you'll be able to configure and manage all of your firewall rules. From a cost perspective, it will also benefit because now, since this network can be configured, your VPC can be configured with a global routing mode enabled, then you can use our backbone, for example, to have connectivity to the VPNs or interconnect links that you have back to your on-prem. So it can ride our backbone and even use our backbone as redundancy, for example, for a 4.9 SLA topology. Which takes us to the next point, since you can provide that resiliency and also disaster recovery, not only within GCP and for connectivity back on-prem, but also when exposing that Anycast, your resources via an Anycast-based VIP. So once you have that VIP published globally and backends in multiple regions, then you can configure your rules in terms of resources and resource allocation. So our Anycast load balancer will send the traffic from your client to the closest backend based on the rules that were configured and proximity. Well, so in terms of shared VPC, on top of all the concepts that that I have covered, you can share that VPC with different projects. So we have a concept of a project, which is a logical container of your resources, including networking and security, for example, in this case. So when you have a model of a shared VPC, you'll have a special type of project, which is called the host project, that you can see here in the larger square. In that host project, the firewall, the network and security administrator, will be able to provision all the networking resources, the VPCs, the subnets, any hybrid connectivity, for example, and the firewall rules, and then share those subnets with the users on the right side. Those users, they will be service project admins, so they'll be able, they'll have permissions to access those recommendation, personalization, and analytics projects, which are service projects. So they will be able to create the workloads, VMs or clusters, GKE clusters, for example, and using subnets that got shared with them. So the VPC itself, it's still defined in the host project. However, the service projects, they'll have the resources and will become shared VPC consumers, if you will. One thing to highlight also in this diagram is you can configure your VPC to enable private access to all Google platform as a service services. So in this example here, BigQuery, but could also be Google Cloud Storage or any other Google provided service. So leveraging our backbone, there is no need to have a public IP to access those resources. So the VPC can be configured, or the subnet can be configured to access those via our backbone. And from a network security perspective, then we have several building blocks that can be leveraged. And also I'm going to cover on how to expand that through our partnership with firewalls. So if we have a look at having the VPC network as the focus, within the VPC, then the VPC firewall rules, they are the tool that is used to control traffic in and out from those resources. So within the VPC, and also traffic coming from the interconnect, coming from the load balancer, for example, or exiting directly to the internet. Now, for incoming traffic, we typically recommend working with our global load balancer that has support for Cloud Armor, which is our WAF, and also Identity Aware Proxy to provide secure access to your applications sitting in GCP. For egress traffic to the internet, then CloudNet can be used as a component to provide a managed service to offer internet access to the VMs that you have in GCP, to the workloads. And for those API-based services for the Google managed platform as a service, then VPC service controls can be used to create perimeters around those services and specify what projects and VPCs and even public IPs that have access to those resources in order to prevent exfiltration for data being hosted in Google Managed Services. Now, as Candice mentioned, the VPC firewall is a layer 4 stateful inspection firewall. So we have partnered with Palo Alto Networks to provide a way to inspect data or to inspect packets at the layer 7. So some of the architectures, so can we move to the next one, Candice, please? So we have currently 2 main architectures that we recommend. So the first one, when using those firewalls like the Palo Alto firewall, it will use a special type of VM, which is called a multi-NIC appliance. Those multi-NIC VMs, they'll have multiple interfaces that will be connected to the different VPCs. So in this example here, which is one of the options available, then those VMs, which are part of a managed instance group, meaning that will be able to auto-scale based on the criteria that was defined, they will have several NICs connected to the different VPCs. In that case here, 4 NICs, so one connected to the Untrust VPC for connectivity to the internet, another one connected to the Transit VPC for connectivity back on-prem, and 2 other VPCs to the projects A and B. So in this case, the traffic between the VPCs can be inspected by the appliances, by those VMs in that case. However, there is a limit in terms of 8 NICs that can be attached to those VMs. So in order to address that requirement, then we have another tool that can be used, another architecture. So Candice, if you go to the next one, please. Which is leveraging VPC peering on the left side. So and on the right side as well. So in addition to the Untrust VPC and the Transit VPCs that we had in the previous picture, now we have new hub VPCs. Those hub VPCs, they'll still be connected to the managed instance group. However, they will be paired with several other VPCs in the spoke projects, if you will. So projects A and B, they're being shown here, and will be configured to export the static and dynamic routes. So in that case, depending on how you configure the redundancy to those firewalls, the Palo Alto firewalls, for example, then those routes will be exported into the VPCs. So all the traffic exiting from the spoke VPCs would land in the hub VPC and then be sent to the appliance and then taking the decision, being inspecting traffic for east-west or also for north-south, depending on the policy. Some of the tools that we have also available that I'm not calling out here, but it would be worth it mentioning, is that on top of the VPC firewall, we also have firewall insights that will provide you hit counts and last used metrics. You can also leverage the firewall rules logging and the VPC flow logs that Candice mentioned, and in addition to packet mirroring to address some of the use cases in case inline inspection is not a strict requirement. So back to you, Candice.
Thank you very much, Osvaldo. So now that we covered some of the benefits of deploying VM service firewalls in your Google Cloud environment, as well as some of the aspects of Google Cloud Fabric that helps you deploy those, now we're going to do a little deep dive. Basically, what are some of the architectural points that I have to consider, and what are some of the common design patterns that we see out there in the field? When you are looking at some of the design aspects of placing the VM service firewalls inside your Google Cloud environments, the first question that you have to answer is, do you wish to use a dedicated model for the firewall stack or a shared model? With dedicated stacks, basically what you are doing is you are creating a stack of firewalls for inbound traffic and probably another stack for everything else, which is outbound traffic, and this is traffic initiated from the inside, for east-west traffic between your service project, and for your hybrid traffic. The other design option is to use a shared firewall stack. Basically, that means, are you leveraging the same firewall stack for everything, for inbound, outbound, east-west, and hybrid? And we probably don't want to go into the deep dive of when to choose which, but basically dedicated stacks provide you predictable performance on each stack and for each traffic flow, as well as the ability to scale them out independent of each other. So basically that's the first decision that you have to make, dedicated versus shared firewall stacks. And if the answer is that you want to use a shared firewall stack, basically you have to use multi-NIC ILB as a next hop, and if you want to use a dedicated stack, basically the ILB as next hop is going to be good enough for you. So the other aspect that you have to look at is how many VPCs you're going to be sharing to your service projects. In some cases, customers basically create just a bunch of VPCs and share those to service projects. We have had customers with just one VPC that is shared across all of those service projects. But in some cases, they want to go beyond that and create much higher number of VPCs to be shared to their service projects. And the reason that is important is that, as Osvaldo mentioned, there is a limitation of 8 interfaces per firewall when we deploy them inside Google Cloud. And also the fact that each interface has to set in its own VPC. So basically the rule of thumb becomes, if you have 6 or more VPCs to be shared to your service projects, include the peering option that will basically help you go beyond that limit. And if that's not the case, basically you don't need a peering. So you don't necessarily have to peer your projects, your service projects to the host project to achieve that, if the number of VPCs is less than 6. And we're going to talk about that in more details a little later. So let's look at some of the design patterns and use cases. The first one that we're going to look at is transit VPC architecture. And basically this means that you're going to consolidating your networking and security within a host project and combine that with a shared VPC, optionally advanced peering to basically deal with the limitation that I just mentioned. And again, it's not a must at all times. Basically, sometimes you need it, sometimes you don't. And then load balancers next hop. One of the customer references that we have in this that follows pretty much the same design pattern is a large US bank that is designing their Google Cloud architecture with centralized Palo Alto Networks securities using host projects and shared VPCs. And that basically gives them the ability to scale out their security posture because they're also deploying an auto-scaling solution, which means that as the traffic load becomes higher and higher, the code is gonna automatically add more firewalls for them and let the security stack basically scale out automatically. The other benefit that they're going to get is a clear RBAC separation between the network security teams and the application teams. Basically, as we will see this a little later, this allows the network and security teams to control the host projects, define all the networking constructs, all the security constructs, and share those somehow to the service projects in which the application teams are basically doing their work. And really all they need to do is to spin up their applications. They don't need to worry about the networking aspects or the security aspects. So now let's look at what this design is going to look like. So as you can see in this case, we have a transit VPC, which is the light blue one within the light blue host project. And then south of that, we have some service projects. In this case, we are leveraging different firewall stacks. So basically, this is the dedicated model. On the left side, I have a pair of firewalls for inbound traffic. On the right side, I have another pair for outbound traffic, east-west traffic, as well as hybrid. So the way this is going to work is you're going to create a load balancer here, which is going to be your ILD as next hub. And this is going to be used as the next hub for all of the service projects. And we're going to talk about that a little later. But basically, that's the whole concept. And again, optionally, I can create some VPCs inside the host project and share those to the service projects and peer those with the trust VPC inside the host project. But that is not always something that we have to do. So it depends on how much you want to scale in terms of the number of VPCs that you are sharing with the service projects. Next, we're going to look at some of the traffic patterns and traffic flows within this architecture. So if you look at an inbound traffic flow, basically that usually, if you follow the red arrows, that usually ends up on some sort of public load balancer on Google Cloud, which is passed to the firewall stack for inbound traffic. And then we do the inspection, pass it all the way through the shared VPC and optionally peering to usually an internal load balancer that sits here in the service project, and then basically that hits the application. So very simple, a load balancer sandwich. Basically, the firewall stack is is sandwiched between two different load balancers. And if you look at the outbound traffic flow, again, that's the case. Usually what I do here is on this ILB as the next hop, I create a default route and propagate that through the shared VPC, and again, optionally the peering to go all the way to this VPC. Basically, what that means is that if you look at this VPC, it's going to have a default gateway pointing to this load balancer. So from the traffic flow perspective, basically your packets from your host, and this is the traffic initiated from inside, is going to land on this load balancer, and it's going to be passed to the firewall stack. We do the inspection, things like URL filtering and basically DLP, and send the traffic outside. We're going to see a similar pattern for east-west traffic. So this is the case that you have two service projects here in the south. They want to talk to each other. Basically, traffic is default routed to the same load balancer, goes to the firewall stack, is inspected, and then returned to the other service project. And finally, we can look at the hybrid portion. So basically, one of the design options that you have here is to kind of like treat your on-prem traffic and hybrid traffic coming to the cloud just like east-west traffic. Basically, bring that on-prem traffic, if you look at the steps here, basically bring that to a separate VPC inside the host project, pass it to the load balancer, and then send it to the firewalls, get the inspection done, and then send it over to the destination. So this basically is the design pattern that we have for some of the customers. This involves separate stacks of firewalls for different traffic flows and a single NIC ILB as next hop. We definitely want to use the transit VPC aspect. We definitely want to use the shared VPC, but the peering option is basically optional at this point. It depends on how many VPCs you want to share to those service projects. And now we're going to look at the other design pattern. So this is the case that you are dealing with a single stack of firewalls. So everything pretty much stays the same, except that your ILB, in this case, is going to be multi-NIC ILB as next hop. And we're going to see why in just a second. One of the customer references that we have here is a large Canadian retailer that decided to build the same security posture experience that they have on-prem with the Palo Alto Networks firewalls into the cloud. And they were looking to secure their cloud, multi-cloud, and hybrid traffic. And again, one of the benefits they're going to get here is the clear RBAC separation between the application roles and the networking and security team roles. So if you look at this design, again, this is kind of similar to the other one, except that in this case, I have only one stack of firewalls. So all traffic, regardless of whether it is inbound, outbound, east-west, or hybrid, flows through the same stack. And again, I will have those basic constructs. I will have the host project. I will have the service projects, the shared VPC. Again, optionally, we can have peering here, same discussion. But the key here is that all traffic flows through the same stack of firewalls. So let's look at some of those traffic patterns. This is an inbound use case, similar to the other one that we had. Traffic usually hits a public-facing load balancer, hits the firewall stack. We do the inspection and pass it all the way through the shared VPC / peering to the service project. And again, we are going to use a load balancer sandwich type of design. This is an example of outbound. So just like before, we basically go ahead and on this load balancer, create a default route, propagate that through the shared VPC / peering to the service project. And then this service project is going to use that load balancer as its next hop. So traffic lands on the load balancer, goes to the firewall stack, we do the inspection, send it outside. This is an example of east-west traffic flow. So in this case, again, we're going to use the same ILB as next hop. We're going to default route everything from one service project to the load balancer. It passes it to the firewall stack. We do the inspection, return it to the other service project. And finally, just like before, you can treat your hybrid traffic just like east-west traffic. You basically bring it in its own VPC inside the host project, pass the traffic all the way to the load balancer, pass it to the firewalls, do the inspection, and then basically send it to the final and destination service project. So basically, we saw some of the very common design patterns that we see out there in the field that our customers are deploying today. Now, at this point, we want to do a quick demo. Basically, we want to show you exactly this architecture. So if I go back here, I want to show you guys the the dedicated stack. So in this case, I will have host projects, bunch of service projects. I'm going to have two separate stacks of firewalls, one inbound, one outbound, and basically we want to test the traffic flow for inbound as well as outbound. So with that, let's switch to our demo. I'm going to start with my Google infrastructure. As you can see here, we have 4 firewalls in this case. So the ones that are up in my firewall 1 and 2, this is my inbound stack, and I have the outbound one, which is my outbound stack. And again, as we mentioned before, the outbound stack not only functions for outbound traffic, but it also functions for east-west as well as hybrid traffic. And again, these are placed in an instance group. So basically, let's switch to our load balancers to show those constructs. In this case, we have an HTTPS load balancer. So this sits in front of the Palo Alto Networks firewalls. Basically, this is the public-facing load balancer. And what we're going to do is we're going to hit the front-end address of this load balancer, and you see that it has 2 healthy backends. The other load balancer that we have in this design is the outbound load balancer. So this is basically used as ILB as next hop, and you can see that we have 2 healthy backends. So in order to do our demo, I am gonna switch to a different browser. And so this pair is my inbound firewalls. What I'm gonna do is I'm gonna hit the outbound load balancer, and hopefully I should see the traffic coming through the inbound stack. And next, I'm gonna start testing from a VM that sits inside one of those service projects, and then it has to go through this outbound firewall stack. So let's do that test. Back in the Google Cloud console, let's grab the IP address of this HTTPS load balancer. And that's going to be the front-end address. And basically, if I move to this tab, I should be able to hit, and I am able to hit the application, which is sitting in the service projects. Now let's go back here. Hopefully I should see the traffic somewhere here, right? So I am basically filtering all traffic coming in on port 80. And basically, as you just saw, this is the current time. So this is where I am seeing that inbound traffic, which is the web traffic going to the Apache server. Also, we're going to do a similar test for outbound traffic. So this is one of the VMs, and this VM is sitting in my service project. And as we mentioned before, this is using my ILB as next hop, or the load balancer as basically its quad 0 route. So hopefully all traffic that I am initiating from here should go to the outbound load balancer and then to the firewall stack, and I should be able to see those logs on the firewall itself. So let's test that. I think I have not allowed the ping traffic. Let me just test with some web traffic. And I got a response. So hopefully I should be able to go here. And in this case, I am filtering all port 80 traffic. Basically, that is coming from the trust side. And then let's see, the current time is 1:58. I have a time zone mismatch here, but this is not that firewall. Let's check the other one. There you go. So that is basically the traffic that we were just talking about. So this is the Google-based traffic. So we initiated the traffic to go to Google's main page. So we basically, what we can conclude is that in this case, with the proposed architecture, we are able to send the traffic inbound to the inbound firewall stack, and everything outbound, east-west or hybrid, to the outbound firewall stack. And that concludes our demo for today. Now, back to the slides. Let's conclude our discussion for today. So we just did the demo. One of the key aspects that customers ask us is, okay, when I want to deploy these VM service firewalls inside Google Cloud, which instance type should I consume from Google Cloud? And then what are the expected performance numbers that I'm going to get? And here's an example. Basically, first of all, we Palo Alto Networks has 4 flavors of VM series firewalls. You can start at the small one, which is a VM100. Our mid-range is a VM300. Then we have a larger instance or license, which is the VM500, uses an 8-core machine. And finally, we have a VM700. These numbers are provided based on the Palo Alto Networks operating system 9.0. So in this case, with VM100, assuming that you're running it on an N1 standard 4, so this is the recommended instance type, the throughput that you're going to get, assuming that you enable the threat prevention and everything pretty much on the firewall, is going to be somewhere around 1 gig. And then if I move to a VM300, which runs on the same instance type, basically my traffic is going to be somewhere around 1.5. Likewise, if I switch it up to a VM500, which is now in this case running on an N1 standard 8, which is an 8-core machine, I should be able to expect 2.3 gigabit per second for throughput. And again, this is assuming that threat prevention is enabled on the firewall. And lastly, if we test that on a VM700, which runs on a 16-core machine, we should be able to get up to 5.3 gigabit per second. So these are example numbers on this version of the code. Obviously, if you were testing this on a previous version of the code or a future version of the code, your throughput numbers are going to be slightly different. And these are publicly published out there. And in case you can't find those, please reach out to your Palo Alto Networks account team, and we should be able to forward those information to you. Okay, that concludes our conversation for today. Here are some of the resources that you can basically take a look at for more learning. On the Palo Alto Networks side, we have reference architectures. So basically, that's a link for the reference architecture for Google Cloud, basically deploying the VM series on Google Cloud. We also have different deployment guides. Basically, these are more in-depth, hands-on types of documents that you can take a look at. And finally, we have the customer-facing data sheets. And I'll pass it to Osvaldo to talk about the Google Cloud resources.
Thanks, Canvas. So I have included a few links as part of our, they're all available in our public website. The first one being the best practices and reference architectures for the VPC design, where you'll find some of the options, and more specifically on how to insert networking appliances. So we have recently released a tutorial, a white paper that covers those options.
Thank you very much, Osvaldo. Thanks for watching this webinar, and hope to see you in the following webinars.